In this video, we're going to talk about the IP3 DAG pathway. And this is one that ultimately leads to the release of calcium. And calcium can act as a messenger, or it can be involved in things like smooth muscle contraction. Okay, so first off, we are going to start by just sort of drawing our simplistic membrane here. Okay, and we are first going to draw our receptor. Okay, so remember again, we have to have a receptor, right? Because that is going to bind to our ligand. Okay, now this receptor has a G protein associated with it. So we'll put our G protein in here again. Okay, so the ligand is going to come in, it's going to bind with that receptor, and what's going to happen is it's going to cause that G protein to dissociate from that receptor. Okay, so here comes our G protein over here. All right, and it is going to go over and it is going to interact with an enzyme known as phospholipase. And I'm just going to abbreviate that PL. Right, but I'll put it up here. Phospholipase. And remember, lipases are enzymes that sort of break down fats. And that's going to activate that phospholipase so that that phospholipase comes over and it will interact with another molecule. And this molecule is PIP2. Okay, so PIP2 stands for, and I'm going to write it up here in the top here, phosphatidyl inositol 4,5 bisphosphate. Right, so all of that is essentially PIP2. Okay, and what's going to happen is that lipase is going to split it into two different molecules. Okay, we're going to do one this color. This one here is going to be known as DAG. And DAG stands for diacylglycerol. And then down here, we'll make this one in sort of a lighter orange. This one here is IP3. And IP3 is inositol, but it's a 3, so it's trisphosphate. So it's inositol 1,4,5 trisphosphate. And what that IP3 does is pretty cool. It's going to come down here. And it's going to sort of insert itself on the smooth endoplasmic reticulum. So this down here is your smooth ER, smooth endoplasmic reticulum. Okay, and what's going to happen is that is then going to activate the smooth endoplasmic reticulum for calcium to leave that smooth endoplasmic reticulum. Now, calcium can do a variety of different things from this point on, depending on the cell. It can be involved in muscle contraction, or it can interact with another molecule known as calmodulin. And calmodulin can then go off and activate something else. Okay, so you are going to see this pathway a lot of times when it involves muscle contraction. Okay, so You'll see it in smooth muscle. Okay, this has also been identified specifically leading to PIP2 and DAG in endocytosis and exocytosis. So if the cell is being signaled to either endocytose or exocytose, right, take things in or release things, you might see this IP3 DAG pathway. All right, so let's go ahead and just like we did last time, let's go ahead and write out the steps again. Okay, so first thing that we're going to see is that our ligand is going to bind to the receptor. That's usually the first thing that happens. And that's going to cause the G protein to dissociate from receptor. And our G protein then is going to activate our phospholipase and our phospholipase is going to split PIP2 into DAG and IP3. Okay. So then IP3 is going to bind to the smooth endoplasmic reticulum. And then the smooth endoplasmic reticulum is going to release calcium. And calcium can activate muscle contraction or activate calmodulin. Okay, so we've talked about now what this IP3 here does, right? But what happens with this DAG? If we go back up here and look at our diagram, okay, this DAG sort of just hangs out here, but it's going to come over and it will interact with a protein kinase, and it's going to interact with protein kinase C. And what does a kinase do? It's going to phosphorylate a protein, so it's going to lead to phosphorylated protein. So here we have two sort of diverging pathways within the same thing, right? Our DAG's going to activate protein kinase C, and then our IP3 is going to activate the smooth endoplasmic reticulum to release that calcium. So I'm going to come down here, right? And what I want to do is I want to add into our steps, and I want to say 5B, DAG activates protein kinase C. And then we'll say like 6B, protein kinase C phosphorylates protein. Okay, so there's our two diverging pathways. And that is the IP3 or DAG pathway.